Hey, my name's Steve and you're watching PageKey Solutions. Today we're continuing our sorts series with part 2, merge sort. So we're on part 2 of 4. We covered quicksort in the last video, and in the next 2 videos we'll cover bubble and insertion. But for now, it's all about merge sort. Returning to our summary and cheat sheet for complexity of algorithms, we discussed last time how merge sort is beaten out by quicksort as they have the same good average case, and quicksort has a slightly better space complexity. However, merge sort, in my opinion, is much easier to implement, so that is one advantage over quicksort. And then obviously its advantage over the other two is that it has a better average case, despite all of them having the same worst case. Let's jump into the algorithm. Some background: it's a divide and conquer algorithm just like quicksort. It was invented in 1945 by John von Neumann, and I recognized that name, so I had to read up on him. And he is also heavily involved in math, invented game theory, and was involved in the Manhattan Project. So if you've heard his name before, it was probably in math class or AI class or wherever else, but his name's out there for sure. Basic steps. As with any recursive method, we have a base case, wherein if the array has less than one element, we do nothing, just return. Because if there's one element, there's really nothing to sort. The first real step is to determine the middle point in the array. This allows us to split the array into 2 parts. Then we call merge sort on the left half and on the right half separately. All merge sort has done so far is find the middle point and then call itself twice, once on the left and once on the right. We have faith that at some point the left half and right half have been sorted by this method. So by the time we get to step 5, all we have to do is merge these 2 sorted halves. So first we can visualize merge sort from the top level. What I just described, in this case, we're just splitting down the middle. So if this is the middle element, then this is the left half, this is the right half over here. Then since we just called merge sort on this half, we do the same thing again, left half, right half, till we get down to the base case where it's just going to return. Here it returns. Here it also returns. Same thing over here. We're splitting down in half, split in half, split in half. Then we get to these one element pieces and they just return. And that takes us back to our last step where we merge the 2 sorted halves. So when we return from 5 and 2, we merge them back into this 2 element array. When these 2 return, they become a 2 element array. Then the 7 merges with the 3 and the 4, and we get things in right order. And these 2 chunks get merged, and everything ends up fine. So it makes sense, but how do we actually perform the merge? Well, we can step through it. I thought the best example would be the one with the largest subarrays from the last slide. So I chose 2 and 5 as our left, and 3, 4, 7 as our right. This one and this one, to get our final sorted array. Our first step is to determine which is less of the 2 sides. We're going to check over and over which side has the lesser element so we can put it in the lowest position in the final sorted array. In this case, 2 in the left array is less than 3 in the right array. So we copy down the left array's value, and then we move the counter for the left array up by 1. And in either case, regardless of who we chose, we will move k for the final array up by 1 because we added to the final array. We perform the same check again, and it turns out that right now has the lesser element. So we'll copy it down, we'll move the pointer for right up by 1, and do the same for our final array. And then we perform the same check. Right array still has the smaller element, so we can copy it down, move it up by 1, and move our final array up by 1. Now the left array has the small one again, so we can copy 5 down, move it up by 1, and we now know left side is done, and we still move that bad boy up. So now that left is done, we're just going to empty out the right hand side. This could be 40 elements left, or just 1 in this case. Either way, we're just going to copy them all down. Right array should already be in order, so we can just copy them into the final array. So we copy down 7, and then J runs out, K runs out, and look at that, we have our array in its merged final order. The good stuff now, the code, we can peek through it. It does everything that we just talked about in the visualizations. And I left in some debug code. But basically, here's our base case. We check, is the array at least 2 elements? If it is, we keep going. Find the middle. The 2 slashes in Python is integer division, which prevents us from getting decimals when we divide by 2. Once we have our middle, we can create our left and right subarrays. So for left, we go from array assumed from 0 to middle. That's kind of abbreviated syntax. Same for right hand side. We're going to go in our main array from the middle to the end. Then we call merge sort for the left side, merge sort for the right side, and merge our main array with the left and right side. So here's our merge method. We're going to merge left and right into the greater R array. So we set I, J, and K to 0, just like in the example. And then we're going to, while I is less than the length of left, basically for every element in I, and while J is less than the length of right, check if I is the smaller element. If it is, throw I into the larger array and increment I. Otherwise, do the same thing for the right hand side. Either way, increment K by 1. So we'll do this until one of the two runs out of elements. Now that one of them has run out, one of these two while statements will execute. Either we're going to empty out the left hand side because it has some extras, which is as easy as adding it to the big array, incrementing I and incrementing K until there's none left, or we're going to do the same thing for the right hand side. Once we're done, we should be completely merged. Thank you for tuning in for this merge sort video. I hope it helped clear up some things on the topic. If you want to check out the full source code on GitHub, run the tests yourself, and mess around with it, I'll take you there right now. So in the source repository, you can just go to sorts and find merge sort. Here's the whole source we just talked about. And here's the test code that you can run for every single one of the tests in this series. If you find a problem in the code, go to issues and open up a new issue. Tell me what the issue is, describe it along with what you saw and what you expected. Once you're done, I'll get back to you as soon as I can. Again, I have to give credit for the icons in this video to Smash Icons and FreePick, both of which I found at flaticon.com, and Time and Space Complexity found at bigocheatsheet.com. Thanks again for watching. Feel free to subscribe and leave a comment to let me know what you thought.